Hello everyone, welcome to the world of electronics. And I think we have something new here. We have 5 circuits here, and let us see the circuit. This circuit 1, it seems there's an LED, transistor, resistor, push button. Circuit 2, there is just the same, but there's a capacitor, small one. Circuit 3, capacitor B, push button, resistor, LED. And number 4, push button, transistor, capacitor, LED, resistor. 5, capacitor, very big. Push button, LED, transistor, resistor here. What is the circuit? So, let us see the circuit here. The circuit of this one LED green is this transistor switch buffer gate. Let us kill the light. Very bright. So we have here voltage supply 5 volts, resistor, LED, resistor, push button switch, and that is the circuit. This is a transistor switch buffer gate. It is a buffer gate. It has a truth table of no input, no output, with input, with output. And this is our previous circuit, and I calculated all the values here of the resistors. And if you like, you can watch my previous video of this circuit, since we know that this is a buffer gate. And let's go. Let us first trace the electron flow here. Voltage supply flows into the collector side of the transistor, resistor, LED, transistor, and to the resistor to the ground. Also here, to the base, to the transistor, to the resistor, to the ground. Also here, when you push the button here, it flows into the resistor here. We need the resistor here to protect the LED. We need the resistor here to bias the transistor and to prevent breakdown voltage, negative resistance, capacitance develop in the transistors, and then leakage current. Also, we need the resistor here to protect the transistor from burning, and the resistor here for the push button switch. This is a pull down resistor, so that our switch will not left hanging. So that is the function of each component. This transistor is operating in switch as a switch in saturation mode. When you push the switch here, current flows here, the LED turns on because also current flows here at the base, making the LED turns on. So that is the basic operation of the circuit. You can watch my previous video, our previous video, in this title. And let's go to the second circuit. This one. I think there's a little light here. Let us try to find out. So our circuit is the transistor dimmer switch. It seems that it's the same with the circuit one. See? What's the difference? I just changed the resistor here. I replace it with the capacitor here. So when you push the button here, the current flows here, discharging it into the transistor, to the base of the transistor. Also, the same operation is happening here, just like this one. The same electron flow or current flows. When you close the switch, the single pole, single throw, and current flows here, also in here, and you push the button and charging the capacitor. At the time you release the button, the capacitor is the one who's supplying the voltage here, or supplying the current here, and still there is a current flowing here. Transistor is in saturation mode, operating in saturation mode as a switch, and that is the second circuit. See, the difference is I just replace it with capacitor. This one is a buffer gate and it's very stable, but unlike here, we saw something in here, a little light. There's something going on in here, maybe a sort of transistor is developing a certain capacitance. They call it transconductance, capacitance, or whatever it is, and some sort of leakage current happening here, or breakdown voltage, or negative resistance. But there's something wrong with the circuit. There's a little light here. And we go to the third circuit with a big capacitor blue here, LED blue, and that is our capacitor dimmer switch. Capacitor parallel with the LED and the resistor here, push button, a regular switch, and a voltage supply of 12 volts. In here, let us check the current flow. When you close the switch, current flows here but stops, and still not turning on the LED because of this push button. And so this is a dimmer switch. Once you push the button, which is normally open switch, current flows here, charging the capacitor, and also current flows here, making the LED light turning on. And once you release the button, the one who's supplying the voltage here, or the current flows here, or the electron flow, or the supply voltage here, is this capacitor until it is fully discharged. Again, when you push the button, charging the capacitor, release the button, discharging the capacitor, making LED on. So this is also our previous circuit. You can check our previous circuit, capacitor dimmer switch, and have some calculation here, time constant, charge, layout. And we go to the port. Seems a little light here, something here, and there's no light here. These two, I constructed it using trial and error. That's my old circuit here. Transistor timer switch. Yeah, voltage supply, resistor, LED, transistor. Also there is a capacitor here in the base side, or input side, push button. Did you see that a little light? There's something wrong with the circuit. And let's try to find out what is that. So first, this is our new circuit, transistor dimmer switch. And the three, this one, buffer gate, capacitor dimmer switch, transistor timer switch, and this is our new transistor dimmer switch. So what's happening here? These two have the same. There is a layout here. It's very odd. That's my design using trial and error. And that is the layout here. Some comments, and this is the circuit diagram. Okay, let's check the circuit here. Push the button, didn't turn on. Why? Because it is dead. It's already busted, defective. I don't know, maybe my old way of soldering it or constructing it or building it. And this one, something wrong with this. There's a little light here, so when you push the button it will light and slowly turning off. Why? Because this is a regular NPN. I'm using C547 here. When you push the button here, current flows here, conducting the transistor in switch saturation mode, also flows here, and charging capacitor here. And when you release the button here, capacitor is supplying the current here to the base, making LED light still light until it becomes so very dim, a low light, but it will not fully discharge. It will not come to that state. Why? Because we have no resistor here. This circuit is not stable. There's no, we can call this a bias resistor here, because without a bias resistor here, or a pull down resistor or a sinking resistor for the transistor, certain breakdown voltage and a leakage current will happen, is happening. Yeah, we're resulting into some sort of a leakage current here. So the LED is still lighting, but a very little. So this circuit is unstable. That circuit is old. These two circuits, and it's not stable. There's little light here. In here, with this person, our capacitor dimmer switch is here. Just push the button and it is stable. Push the button, release, and then the light is dimming slowly, because the one who is supplying the current here to the LED is the capacitor. When you push the button, charging, release, discharging, until it is fully discharged. This is also our previous circuit. We calculated a lot here, time constant or anything, until it is fully discharged. This circuit is stable. We have a big resistor here, making the discharging so slow, or it discharges so slow, or slow discharging will happen, or resulting slow. And this one is our transistor dimmer switch, our new project. And this circuit is from this circuit, transistor buffer gate, and the combination of the buffer gate, just a buffer gate. I just replaced the resistor here with capacitor, and when I replace it, there's something wrong here. And you push the button, the LED turns on, slowly discharging, but it did not discharge completely. Still a little light, something going on here. Why? Because I replaced the resistor here, which is this one, with the capacitor here, making the circuit unstable. So since this circuit is stable, and this is a buffer gate with a truth table of this, when you push the button, see, just a buffer gate, no input, no output, with input, with output. There's no leakage current or breakdown voltage is happening here, or some sort of that. Like here, there's a dim light here, also here. It seems there is a leakage current happening here. So the same computation is we have here, the same, almost the same here, just like this one. So let us examine the current flow of this new circuit. When you close the switch, current flows to the resistor, LED, transistor, into the resistor. Also, current flows here at the same time. But it did not flow here, stops here because of the push button. So, the LED didn't turn on. When you push the switch, still current flows here, and here, and also here. There are 3 loops. 1 loop, second loop, and the 3rd loop. Also, we need a resistor here to protect the LED, resistor here to protect the transistor, resistor here to bias the resistor and to prevent leakage current. But still, there's a leakage current here. Or maybe that is the result of eliminating this pull-down resistor, leaving the push button hanging. That's why there's a little light there. I think I need a pull-down resistor here to stabilize the circuit. So, let us compute the value of each component. RD here by using Kirchhoff's voltage law. Voltage supply minus voltage drop, voltage drop, voltage drop, and here. And we get this one. 6.8 volts. Voltage RE at voltage RD. Since they are in, I just use a voltage divider here, dividing it into 2, and we got 3.4 volt each. Voltage drop 3.4, 3.4. We know now the value of the voltage drop using Ohm's law. We got 220 ohms. Ohm's law. We know the voltage in the RD, and this 0.0 is given in the data sheet. And also, we can calculate the emitter current using this formula, IC plus IB. But before that, let us compute IB here by using current link formula here. HEP IC IB 0.02 collector current is the same as the current in the diode and the resistor. 0.02 given in data sheet. And an HEP 400. HEP transistor is 400. I'm using a transistor C547C NPN. And we got base current of 0.0005 ampere. Now, let us see the voltage drop across the RB. We're going to use a simple Ohm's law here. When you push the switch, there's a supply current flowing here. Push the button here to the resistor and to the base emitter. We just calculate up to here, base to emitter, because we are trying to find what is the voltage drop here, and just to turn on this transistor, we're using this formula. An Ohm's law, just to turn the transistor on. Voltage supply minus voltage at RB, and then voltage base to emitter saturation given in the data sheet, and this is 8.1. we just use this formula to know what is the voltage drop here, and the transistor is operating as a switch. Just compute for this value, and using Ohm's law we get now this 162 kilo ohms. I use 162.2 kilo ohms. Since we know the base current now and the collector current, the current and the emitter is the sum of the IC plus IB. IC, IB, but because that is a transistor formula. We got RE, we know the voltage drop across RE and the current E, the sum of the IC, IB, and then we got this RE, 160, but I use 220 ohms. And when you push the switch, capacitor is charging. How long will it take to charge capacitor? By using time constant. That is the formula used to charge or discharge capacitor. Tau, or time constant, is equal to resistor times the capacitor. Resistor must be in ohms, capacitor must be in farad. And you see that computation here, I am using 1 microfarad. That is not 100 microfarad. I changed it to 1 microfarad. The computation, it becomes 0.1622 seconds to charge and discharge. And to fully discharge and discharge the fully charge and discharge the capacitor, we need 5 tau, 5 times constant, 5 RC, and we got 0.811 second to fully charge or discharge the capacitor. That is the time, the amount of time needed to charge or discharge the capacitor. And this is the pin out of the transistor. So what happened here is still the circuit is not stable. I replaced the resistor here with the capacitor here, making the switch floating or indeterminate state. It has no state. It should be 0 or 1 because this is some sort of buffer gate. There's no input. The switch didn't know what its input. You need to have this resistor here to pull down, making it a state of 0, some sort of that. And we have given here some given parameters here, and also pin out, and that is our final circuit with its value, and the layout is this, and the actual circuit is this, and the parts are here. I'm using 4 resistor here equal to 162.k kilo ohms, 1 microfarad, push button switch breadboard, voltage supply to 20 ohms, LED red. And I think we discussed all the circuits here, and although there's some problems here, but still this is our circuits. We're going to put some resistor here, or 1 resistor here, pull down resistor for the switch. I need a pull down resistor for the switch. This resistor is for the transistor biasing, a resistor for the base current, and a resistor for the LED. And there's we put a resistor here, maybe the discharging effect will become so fast. It will become much faster than this one. Okay, thank you for watching the video, and bye.